Okay, so I will be going over some sample problems for the upcoming exam. All right, so typically structure of the test is pretty similar to what you're used to. A lot of times I'll have some multiple choice questions where you don't have to show any work on or anything, just sort of knowledge-based questions. So to begin with, how do you tell if a function is one-to-one? Well, what you have learned to look at is the horizontal line test. Okay, not to be confused with the vertical line test. Remember, the vertical line test tells if something's a function. So if you took vertical lines would only pass in one point. So this is a function. But if you take horizontal lines through this, it's going to fail. And all you got to do is find one line that fails. So if I take a horizontal line like that, notice that it's going to cross through 2 points. So that would be no as the answer to that problem. Okay, next problem is this an inverse? Well, you got to look at symmetry. If I give you a graph, you can tell something's an inverse based on the symmetry of it. So basically, you got to just see that it's symmetrical about this line, y equals x. You can pretty well tell by looking that that's symmetrical. In other words, if you took this point, a good way to kind of look at this is like this point right there. I don't know, it might be the point, it's hard to tell, but 210. So that would change into the point 10, 2, which looks like it's a point on the graph. And every point has that characteristic on an inverse as the x and y coordinates get flipped. So this one would be a yes. That looks like an inverse function. Okay. Let's see, next problem. We want to find f of x, find f of negative 2. Okay, so what you would be doing on this is just evaluating f of negative 2, which just means you're going to replace x with negative 2. Partially what I'm looking to see on this is that you guys can handle these negative exponents. Okay, so that would be, if you have a negative exponent, you can write that as 1 over 5 to the second, and then 5 to the second is 25, so the answer to that problem would be 1/25. Okay, okay, now next problem. We learned about system of equations. So one of the things you want to be able to do on this is, okay, what is the solution of this system of equations? Well, what you got to do is you got to find the point of intersection. Okay, so with this one, it's just kind of a knowledge-based question. And it looks like the intersection point, gosh, I can hardly see on this. It looks like it's 1 and negative 3. Okay, now, one of the things you want to do if you encountered a problem like this on a test, you know, it's pretty easy to tell that you're right on this if you can figure out the intersection point. But one thing I want to reiterate here is if it's a solution, then it should check in both equations. Okay, so if I replace x with 1 and y with negative 3, it should work. So notice this is 1 plus 5 times negative 3. That's 1 minus 15, so that is equal to negative 14. So it definitely works in that equation. And then if I replace the second equation with 1 and negative 3, I get 5 times 1 minus 5 times negative 3, so that's 5 plus 15. So that's 20, so that also works. Okay, so you can tell you're right on that problem, even though it's pretty easy to tell what that intersection point is then. Okay, if you had two lines and they didn't intersect, they were parallel, then it would be no solution. So there's a lot of varieties of ways that I can test you on that problem. Really two fundamental ways. Okay, so this says match the graph to the correct inequality. So the first thing that you'd want to see on this, and I'm going to zoom on this a little bit as I go through so I can see this a little bit better. So it looks like, first of all, what we have is we have the line x equals 2. You have a vertical line that's going through x equals 2. You have a solid boundary line, and then you're shading to the right of this. So you're going to say x is greater than or equal to 2. So shading to the right is greater than, shading to the left is less than. Now if I had a boundary line like that, then you would say x is greater than 2. Okay, so you want to be sure that you're solid with the way the boundary lines go and everything as well on that. So that's just kind of a simple multiple choice question where you're kind of seeing that you know how to write things in terms of an inequality. Okay, now these next couple of things are talking about properties of logarithms. So the first thing on this number 6 is a couple of things you want to know. We do have a property of logs that says if you have a number, p, and in the exponent you have a logarithm with the same base, and these things have to match, then it turns out that whatever you're taking the log of, if that was a t, then the answer would be t. Okay? That's a property that you got to know. All right, so what you want to look at on this problem is this is really 10. If you have an log without a base, remember that is understood to be a base 10. So that means these things match. So whatever this expression right there gives the answers. The answer to that problem is A or T. Okay, the next one is kind of testing this, all right? And if you forgot this, well, first of all, if you're taking a log of any base, you can't have a negative number there. Okay, you also cannot have a log of 0. Those are two things that you can't have. The only thing that you can take a log of is a positive number. So this one would be undefined. Now, if you forgot this, let's just say that you didn't see this on this problem, then you could say log base a to -1. You could set that equal to x and try to reason out the answer. So you could write this in exponential form, so it would be 8 to the x equals -1, and hopefully you would see there is nothing you could put in this box that would make that -1. Okay, anytime you take a number to any power, and I'm talking any power, you always get a positive number. You always do. Okay, so that's important to understand that any positive number to any power is positive. Even if that's a negative exponent, it's positive. So even if you had like 2 to the -4, well, what is that? That's 1 over 2 to the 4th. That's 1 over 16. And that's a number that's greater than 0. Okay, so that's real important to understand. You can't do a log of a negative number or 0. Okay, now moving on. Next things that you want to know about logarithms is how to change these things back and forth from exponential to logarithmic form. Okay, so what you study on this is you know that if you have log base b of some number, we'll just call that number p, is equal to some number q, then that's the logarithmic form. The exponential form is b to the q is equal to p. So one of the things you want to know how to do is how to convert a logarithmic form to an exponential form. If you don't know how to do that, you'll struggle mightily on this exam. So you want to be sure you know how to do that. All right, so basically in this particular problem, this is in an exponential form. So we're going to convert this form to this form. So you're going to have a log. And the way I always remember this is the base. So that thing has got to be the base of the logarithm. So that's 5, 6. The other thing I remember is the answer to a logarithm is an exponent. So the answer's got to be 3. And then what's left over is what you're taking the logarithm of. Okay, so that would be the answer to the problem. So that seems to match with this one. Log of base 5, 6 of this expression is equal to 3. That would be the appropriate answer to that problem. Okay? And so you can tell you're right, because all you do to tell you're right is take this number to this power is equal to this. That matches what I gave you. 5, 6 to the 3rd is 125 over 216. Okay? Okay, next situation. This is a logarithmic expression, so you're going to change this to exponential. Exponential expressions have this structure. Okay, like that. So you just say the base, okay, and when you're doing this to the 1/3 power is equal to 4. Okay, when you're doing logarithm, remember the answer to a logarithm is an exponent. So that goes there. So you would end up with 64 to the 1/3 power is equal to 4. So that would also be choice D. Okay, so those are some examples of some multiple choice questions. There's all kinds of things I can ask. Those are just some examples. Next thing you want to know how to do without a calculator is just evaluate different types of logarithmic expressions. I'm going to do these, and then I'm going to also do a few more. Some of these you can do in your head, and if you can do it in your head, you don't have to show any work on these. So one strategy for these is just to set these equal to x, then write in exponential form. So if you wrote this in exponential form, you would have 4 to the x equals 64. So these problems are designed so that you can do these in your head. So 4 to the third is 64. And remember, the answer is whatever the exponent is, so the answer is 3. Okay, next problem could be done exactly the same way if you need to. Set it to x, write it in exponential form. So that's 4 to the x equals 1. The meaning of this problem is 4 to what power is 1? The answer to that is 0. So the answer is the exponent. So then you would have your answer of 0 like that. These are intended to be problems that you can do in your head. Okay, now there's several ways to do this next one. I'm going to again set this equal to x. And remember, if you have an ln is a log base e. So technically the question you're being asked is log base e of the expression e to the 9th. Now if I set that equal to x, then I would say e to the x is equal to e to the 9th. Okay, again, you're taking the base to this power and setting it equal to what you're taking the log of. Well, the only thing x could be is 9. So the answer to that problem is 9. So that would be one approach to doing that problem. Another approach to doing this problem would be you could take ln e9. Remember, if you have an ln of a number to a power, you can bring that down in front and get 9 times ln e. And then we learned that ln e is 1, so you would get 9. So you can look at it like that. Okay, now next thing here. This one either you know is 1 or you can figure it out. If you forget that it's 1, just do this. This is really saying the log base e of e. Set it equal to x. So now you're going to say e to the x is equal to e. Again, you take the base to this number and set it equal to the number you're taking the log of. Okay, the only thing this could be is x equals 1. So ln of e is going to be equal to 1. All right, those things can be figured out. You don't have to memorize all the properties. You can figure them out. Okay, next thing is, another important thing is if I give you an expression with one log, you want to write it as a sum or difference of logs when you do these then. Oh, come on. Okay, so I'm just going to review the properties on here that we have. You really got to use several properties. So if you have a log base b of a product of two numbers, remember this one is the one that can be broken up into the sum of the logs. So we're going to end up utilizing this property sum in this problem. So that's a property, that's one property. Second property we learned is if you have a log base b of a fraction, m over n, then you can break that up into the difference of the two logs. So you could say log base b of m minus log base b of n. And then the third property that you use on this problem, for the most part, is going to be log base b of m to the n. If you had something like that, then remember you can bring that exponent down in front to get n times log base b of m. Okay, so you have that. Other things that you want to do frequently on these problems, if you have a nth root of x to the m, that can be written as the x to the m over n power. Anytime you have a radical, the name of that radical is the denominator. Just try to remember it like that. So we're using all of these properties in this problem. So I'm going to start off, since I have a log of a difference, or a log of a fraction, sorry, we're going to actually start by using this property. So step one is we're going to write this as log base 2. And I'm going to put this in parentheses. You don't actually have to do that. But seventh root of m times the third root of n minus the log base 2. Correct that. Log base 2 of k to the second. Okay, so that's step one, is to apply that property. Step two is if you have a log of a product, you can break it up into a sum. And that's clearly what you have here is a log of a product. So you can bring this down and you get log base 2 of the 7th root of m plus the log base 2 of the 3rd root of n minus the log base 2 of k to the 2nd. Okay, so we've now used that property. Okay, the other thing that you want to do is you want to look at property 4. So this technically, you can think of this as 7th root of m to the 1st and 3rd root of n to the 1st. So you can rearrange this and write this like this. You can say log base 2 of m to the 1/7 plus log base 2 of n to the 1/3 minus log base 2 of k to the 2nd. Okay, so now what I can do is I can bring those numbers down in front. So these are exponents, so the exponents come down in front, so we're applying this property 3. So we're going to bring these down, and then we would have the problem finished. So we'll have 1/7 log base 2 of m plus 1/3 log base 2 of n minus 2 times log base 2 of k. So that would be the official answer to the problem. Okay, so you want to be prepared to do that kind of a thing. This is just a simple way to check that students know these basic properties, and you're always on these problems pretty well using these 4 properties right there in some ways. Okay, all right, so that's how you would do that. I want to practice on those type of problems. Okay, next thing is a log equation, and with this one, again, you got to use a property of logs. The property of logs that you have on this one is if you have a log base b of m plus a log base b of n. Okay, this is saying that you have a product of 2 logs. You have a sum of 2 logs, so you can write this as 1 log of a product like that. So that's how you're going to start this problem, is you're going to put these 2 logs together like this. So you're going to say log base 7 of x times x minus 48 is equal to 2. All right, now you can write this in exponential form. So the idea is if you have a log base b of p equals q, you can write that as b to the q equals p. So we're going to do that. We're going to say 7 to the 2nd is equal to x times x minus 48. Now you're just going to solve this equation, and this is a quadratic equation, so you're going to use the methods that you learned to use to solve quadratic equations. 7 to the 2nd is 49. Multiply this out with the distributive property, you're going to get x squared minus 48x. Get one side to 0, so I'm going to subtract 49 from both sides to get this. Okay, now what I'm going to do is I'm going to solve this, and this is either going to be factorable or it's going to require the quadratic formula. So this one should be factorable. So we're going to put x and x, find numbers that multiply to give 49 that add to 48. That's going to be 49 and 1 with a minus and plus. Be sure if you factor something that you take the time to verify that's right. So notice that you have negative 49 plus 1. Negative 49 plus 1 gives negative 48. Then what you do is you set each factor equal to 0. So we say x minus 49 is 0, and we say x plus 1 is equal to 0. So this equation would produce the answer 49, and then this equation would produce the answer negative 1. Now, what I'm going to do is you've got to be sure on these problems that you check your answer, because they don't always work. So let's start with the 49. So we're going to replace, let's start by just replacing the x with 49 over here at the side. So that would give us log base 7 of 49 plus log base 7 of 49 minus 48. And let's work that out. So that would be log base 7 of 49 plus log base 7 of 1. Okay, well, the log base 7 of 49 is 2, because 7 to the 2nd is 49. And then the log base 7 of 1 is 0, because 7 to the 0 is 1. So that, definitely checks out. So we know that without a doubt, 49 is an answer to the problem. Okay, now we need to see what happens if we replace the x's with -1 then. Okay, so let's go ahead and do that. Let's plug -1 in. And if you do that, you're going to have log base 7 of -1 plus log base 7 of -1 minus 48. Now here's the deal. You cannot take a log of a negative number. So that means this one cannot be right. So you have to throw that out. That's an extraneous solution. It will not check because you cannot take a logarithm of a negative number. So that means the only answer to this problem is going to be 49. These problems very, very typically contain extraneous solutions. Not always, but often they contain extraneous solutions. Okay? All right, so that's how you'd want to do that. That's a very typical kind of problem as far as a logarithmic equation goes. Okay, next thing we're going to do is I give several logs. There's 3 logs. And you're going to write this as 1 log. You're going to end up having 1 log. So what you're going to do is utilize these properties again. So let me just review these real quick. The log of a product is the sum of the logs. So we know that. That's one property. Second property is a log of a quotient is the difference of the logs. That's another property. And then a third property that we use pretty frequently is log base b of something like p to the q is q times log base b of p. Okay, so we're going to probably utilize these logs. So the first thing you got to do is before you can put the logs together, any number that's in front of a log has to be brought up into the exponent. So step 1, you have to start this way. So you're going to utilize really this property right here at the beginning of the problem. So let's do that. We're going to have logarithm base 5 of x to the 5th plus logarithm base 5 of x to the 1/8 minus logarithm base 5 of x plus 7 to the 2nd. Okay, so we got that as step 1. So we've used this property right here. Okay, now what we can do is, see, these are a sum of 2 logs. So a sum of 2 logs gets put together like this. So we go ahead and write this as logarithm base 5 of x to the 5th times x to the 1/8. Then we can bring this down like that. Okay, so we've utilized that property. Now what you notice is we have a difference of 2 logs. Okay, so that means we can put these together into the log of a fraction. Okay, so what we're going to have next is we'll write logarithm base 5 of x to the 5th times x to the 1/8 all over x plus 7 to the 2nd. All right, now we've accomplished everything. The only thing we really need to do is we can do a little algebra. So I do want you to do algebraic simplifications. This is really the property where we add exponents. So if you had x to the 2nd times x to the 4th, you know that you add the exponents. You do the same thing here. So you're just going to do x to the 5 over 1 plus 1/8. So you're going to get a common denominator, which is 8. And then that's going to give x to the 48 plus 1/8. So that's x to the 41 over 8. So for your final answer, you'd have log base 5 of x to the 41 over 8 all over x plus 7 to the 2nd. Okay, problem done because you've got this down into 1 log, and there's nothing in front of the log. That's how you know you're done, right? So that would be the final solution to that problem. So it's important that you know these properties of logs. I do not give you these properties of logs. You need to know all these properties. So you want to be sure you have those down. Okay, next thing, a very typical kind of problem that I find to be pretty important. Okay, so what we want to do is we want to take this log function and we want to start by finding its inverse. Now, you could automatically know this. I mean, I would hope that a student just automatically knows that the inverse of log base 2x is 2 to the x. Okay? Now, you could also do this. If you happen to forget this, Well, what you do is you do what you do on inverses anyway. You could switch the variables and get x equals log base 2 of y. Then you could write this in exponential form. So you say 2 to the x is equal to y. And that's what you get. So it's very easy to do that. Okay, next thing we want to do is we want to do a table of values for the inverse of the log. So this is the way I want to guide you through this problem. So I'm going to insert a table here, just maybe making enough table of values for the inverse. Then what I'm going to do is I'm going to go ahead and make a table, a second table when I do, whoops, didn't want to do that. I don't know what in the world I just did. Okay, so let me go ahead and copy this, and let's paste it a copy of that. Oh, I tell you what, this thing sometimes it just doesn't do what I want it to do. Let me try one more time. See if I paste it over there. There we go. Okay, so all right. So here's what I want to do is let's make a table of values for the inverse. One of the things I said, when you graph a logarithm, it's a lot easier if you graph its inverse first. So we're going to make a table of values, and we're just going to graph f of x equals 2 to the x. That's the inverse that we found. Okay, so let's just use -2, -1, 0, 1, and 2. That's the typical values you use for an exponential function. So starting here, we'd have 2 to the second is equal to 4. Again, I'm plugging the x value into x, so then we'd have 2 to the first is 2. 2 to the 0 is 1. 2 to the -1, you want to write that as 1/2, because remember that's 1 over 2 to the positive 1. 2 to the -2 is 1 over 2 to the positive 2, so that's 1/4. Okay? So they want you to graph the inverse and the logarithm on the same coordinate system. So what I'm going to go ahead and do is I'm going to go ahead and just, plot out these points and graph the inverse. So we have a point 0, 1, we have a point 1, 2, and we have a point 2, 4. And then we can go through and just use a dashed line or whatever, and we can label that. So I'm going to go ahead and just graph out that inverse like that and label that y equals 2 to the x. Or I can, and that's fine if you label that way. Since it's an inverse, I'm going to label that as f inverse of x is equal 2 to the x. Okay? And remember what happens on an exponential function is it levels off at the x-axis. You don't have any negative values for y. They're always positive. They just get smaller and smaller. So now what we want to do is let's graph what I gave you. Let's graph the logarithm. So we have log base 2 of x. So what you do is, since these things are inverses, just switch the points. So just go 4, 2, 2, 1, 1, 0, 1/2 -1, 1/4 -2. And then you can plot these things, and you can plot them very, very easily. Okay, so let's plot the points. Start with 4, 2, put a dot. 2, 1, put a dot. 1, 0, put a dot. Now you can go through and you can graph this. So the logarithm function will kind of go like this. And again, this one levels off at the y-axis like that. So that's the graph of y equals log base 2 of x. So that's a very typical problem that I like to have you guys know how to do. Don't change that very much. It's just, do you understand how to graph a basic logarithmic function? Okay, so no transformations, just a basic log function. So that's the approach. Okay, next thing is exponential function with some transformations. So I'll show you a couple of ways to do this. And again, the first thing to do is to look at what these transformations are. Okay, so we have y equals -2, x plus 1 minus 4. Okay, so the thing is, if you are inside of the exponent, you're affecting x. So this is affecting x left or right. So since that is a plus sign, that means that we're going to be transforming this function to the left one. So that's a transformation. Anything that's outside of the exponent is affecting y values. Okay, so that means that's an up-down thing. You're making y's get smaller. So that means you're going to go down 4. Okay, so that's what that means. Okay, and then again, anything that's outside of the exponent, that's still outside the exponent, that's affecting y. So what this is really doing is it's multiplying y by -1. So if you had a y value up here, it would go down there. Y value up here, go down there, so that's reflect over the x-axis. So you want to know all of your transformations and how they work. Now this problem, you can get this problem right if you take the time to do basic arithmetic on this seriously. Okay, so I'm going to go ahead and make a table of values on this. And let's go ahead and just make a table of values for the basic function y equals 2 to the x. I do want you to graph that. So let's go ahead and do x. And let's do y equals 2 to the x. Okay, so we already did that in the previous problem too, so that kind of helps you out on that. So let's use -2, -1, 0, 1, and 2. Crunch it out real quick. 2 to the second is 4. 2 to the first is 2. 2 to the 0 is 1. 2 to the -1 is a half. And then 2 to the -2 is 1/4. And then we can go ahead and we can plot those points. So we got a point 0, 1. We have a point 1, 2, 2, 4. And then we can connect that and label this as our graph of the basic exponential, y equals 2 to the x. So it's good enough if you just get those points and then make sure you make it level off towards the x-axis like that. Okay, now what you can do is if you want to do this, you can either do a table of transformations the way I taught you early in the semester, which I'm going to do, or you can also just make a table of values. Students a lot of times on this don't realize that if they just apply basic arithmetic skills, they can get this right. So I'm going to show you how to do that, but I'm going to go ahead and make a table of transformations on this. So let's go ahead and let's write out our points. So we have a point -2, 1/4. We have a point -1, 1/2. 0, 1. 1, 2, and 2, 4. Okay, now when we do these transformations, remember there's an order to this. So if you have a left-right transformation, you want to do that first. So the transformations we came up were left 1. You always got to do this thing first. That's the first thing. You got to order of operations. You got to work with this. Then you got to multiply. So the next thing you're going to do is you're going to multiply y by -1. And then the last thing you're going to do is you're going to go down 4. Okay, so you can do this table of transformations if you want to do it this way. I don't require you to do it this way, but it is a nice way to do that. Or you can just do it in your head, or you can make a new table of values. It's really up to you. I'll show you all the different ways you can do this. So what I'm going to do is go ahead and let's make up our table and just kind of go through the details of this one by one then. And you can do the transformations, and then you can plot your points, and then you should have a valid graph, assuming you do all of your arithmetic correct then. Okay, so let's start by doing this. If we're going to go to the left 1, first thing is the y values are unaffected by that transformation. So I'm just going to write those y values down. And then these things are going to go to the left 1. So you can do this in your head if you want to, okay? That's going to go to -3. That's going to go to -2. That's going to go to -1. That goes to 0. That goes to 1. All you're doing is making those numbers get smaller by 1. Okay, so that takes care of that. So the next thing is, when we multiply y by -1, the x values are unaffected. So we've got our x values in the right location. Now what we need to do is we need to transform these by multiplying by -1. So all that's going to do is make -1/4, -1/2, -1, -2, -4. So we got those points now. Okay, now we got one more thing to do. We got to go down 4. So again, when we do our points, Down 4 doesn't affect x values, so we're going to leave this alone. Then we're going to take all these points and we're going to take them down 4 to get our final answer then. Okay, so what we'll end up doing on this is down 4. So negative 4 minus 4 is down to negative 8. Negative 2 minus 4 is down to negative 6. Negative 1 minus 4 is negative 5. Negative 1/2 minus 4 is negative 4.5. And then negative 1/4 minus 4 is negative 4 1/4. So those would be the values that you plot. So what we want to do is go to our graph now. We want to plot these points, and then we've got the problem done. Okay, so that's what I'm going to do. I'll just pick another color, like say green. So if I plot the point 1, negative 8, that's going to be there. If I plot the point 0, negative 6, got that point. Negative 1, negative 5. Negative 2, 4.5. Negative 3, you can kind of see how it's sort of leveling off like this. So basically what you have is, since you moved everything down 4, you actually have a horizontal asymptote at negative 4. Then you can just plot in the graph like that, and then you're all done. So that's one way to do that problem, is to do that and get all those points taken care of like that. Okay, so you've moved everything left 1. You've reflected it and you've moved it down 4. So you can do it that way. Now an alternative way to do this problem, if you don't like doing it the way I just showed you, is you could go ahead and make a new table of values. So you could do x, and then you could do y equals negative 2 x plus 1 minus 4. All right, now what you can do on this is you could use these same values, or you could use as many values as you want. Let me just show you what happens when you use these same values. All right, so let's start with 2. So you could do negative 2 to the 2 plus 1 minus 4. Okay, so that is negative 2 to the 3rd minus 4. Now you got to do this. So see, that negative is not a part of what's being cubed. So that's negative 8 minus 4. So that's negative 12. Okay, so you get a point to negative 12. Move on to the next one. You got negative 2 to the 1 plus 2. Again, I'm plugging in for x, or the 1 plus 1 minus 4. So that is negative 2 to the 2nd minus 4. This thing right here is 4, so it's negative 4 minus 4. That's negative 8. Okay, so you got that. And see, that's the same thing we got here. You got 1, negative 8. So it's matching up with what I did in my table of transformations. Then do this. Negative 10 to the 0 plus 1 minus 4. That's negative 2 to the 1st minus 4. So that is 2 to the 1st is 2. Negative 2 minus 4 is negative 6. And that gives that point. And then you could do that over and over again, and you get the same value, see? So you can do that either way you want to. Okay, when you do that. I find it just as easy to do that table. I think that's how students make the greatest connections on these problems, is by doing that table. Okay, so that's another fundamental thing you want to be able to do, is graph an exponential function when you have different transformations of different sorts. Okay, so the next thing I want to review how to do is a inverse. All right, so, and I'm giving you that it's a one-to-one function. So when you do an inverse, typically what you do is you just write this as y equals 3 over 7x minus 2. And then the first thing that you want to do after you do that is just switch the variables. Mainly just kind of a two-step process. So change the y to x, change the x to y. Then the second thing is you need to solve this equation for y. Okay, so there's several ways you can go about doing this. This is an equation that's got a fraction in it. So my thought process is I have a fraction, therefore I want to get rid of it. So I'm going to multiply both sides of this equation by 7y minus 2. So that's going to give 7yx minus 2x is equal to 3. Okay, then what I'm going to end up doing on this is I'll go through, I'm going to move this over here. I need to basically get everything that's got an x in it needs to go to the other side of the equation except this. So I'm going to move this to the other side. So I'm going to have 7yx is equal to 3 plus 2x. So I'm going to add 2x to both sides, see? Okay, so now what I'd like to do is if I want to get y by itself, I've got two numbers multiplied by y, so I can divide by those two numbers, then I get that value. Okay, so what I get is I get y equals 3 plus 2x over 7x. Doesn't matter what order you write that in, and then you really want to write your answer as f inverse of x is equal to 3 plus 2x over 7x. So that would be the final solution to that problem, right? Okay, so that's how you do inverses. We've done that quite a bit. Switch the variables and then solve that equation for y are the key steps that you follow on that. Okay, so there's your answer. Okay, so be prepared to do an inverse of a one-to-one function. Okay, next thing we want to review is the stuff we did in Chapter 6, just doing a system of equations. Typically what I like you to do in this exam is be able to solve a system of equations either by elimination or substitution. I can ask that either way. Sometimes I even give you the choice to do it by substitution or elimination. Okay, so if we're going to do this one by elimination, the first thing is you get to decide which set of variables that you want to eliminate. Okay, my thought process on this one would be I would probably like to eliminate the y's. That's already a 16, so if I can make that negative 2 become negative 16, then I'd be able to eliminate that variable. You could also eliminate the x's, although if you did that, you would have to work with both equations. So my thought process on this one is, if I take this negative 2y, and if I multiply that by 8, I get negative 16y, so that would cancel with this. So what I'm going to go ahead and do on this is I'm going to take the second equation, and I'm going to multiply it by 8. Be sure that you do the same thing to both sides, or you're going to change the problem. So I'm going to bring the first equation down. I don't need to touch the first equation, so just rewrite it. Then the second equation is going to be 24x minus 16y is equal to negative 16. Okay, now what I can do is I can add these equations together. That's going to cross out. That's going to be 32x, and then this is going to be 0. So I'm going to move this over here so I have 32x equals 0. So I can divide by 32, so that gives x equals 0. You're going to write your answer as a intersection point. So we've got x. That means we just got to find y. So if you want to find y, you go back to either of the original two equations. It's totally up to you. You'll get the same answer regardless. So I'm just going to work with the top equation, and what I'm going to do is just replace x with 0 and then solve that equation. Okay, so that's going to give x times 0 plus 16 times y equals 16. So that's 0 plus 16y equals 16. So that's 16y equals 16. Divide by 16, and then you get y equals 1. So that should be the point of intersection. Now, one thing that you want to do on an exam, if you feel like you have a lot of leftover time, one of the things I think some of you haven't done a good job of is checking your answers. Okay, it matters on a test, so why not check your answer if you feel like time allows? So all in the world you'd have to do to check your answer on this problem is just do this. You'd just go, I'm going to put the checking up here. So I've got 8x plus 16y equals 16. We're going to check that equation. Then the second equation is 3x minus 2y equals negative 2. X is 0, so plug in that. Y is 1, plug that in, and check it. So this is 0 plus 16 equals 16. That works. Now go to the second equation. X is 0, y is 1. Check it out. So that's going to be 0 minus 2 equals negative 2. That works, so that means you have the right answer to the problem. Now see, that only takes, less than a minute to do that. So it's important. Okay, next thing we want to review is how to solve the system of inequalities. Okay, we solve this by graphing. So we're looking at a shaded region. So I showed you a couple ways to do this. I thought one of the better ways to do this, I think, for students is just to solve these for y. At least the first equation, and the second equation is just x is greater than or equal to negative 1. So what you got to do is you got to solve these two. I'm going to go ahead and start by doing this. Okay. So we can do this. That is if we just do this line, see, we can graph x equals negative 1. We know that's vertical, and it goes through x equals 1. And we also know that this, since there's a greater than or equal to, that's going to be a solid boundary line. Okay, so what I'm going to do is I'm going to go ahead and just graph that. I'll pick a color and graph this one, say, in blue. So I'm going to go ahead and I'm just going to graph a vertical line through x equals 2. Okay, so we got that. All right, now what we're graphing is x is greater than or equal to negative 1, like that. So what that means is we're going to be shading to the right of that. So I'm just going to make a little indicator that I'm over in this area for sure. Okay, sometimes I tell students to put little indicator arrows to make sure they know that. So that means you're not going to be graphing here. You can rule that out right now, say. Now what we can do is solve this equation for y, or that inequality for y. So I add x to both sides to get 4y is less than positive x minus 16. Okay, then what I can do is divide both sides by 4. And then that will give y is less than, see, this is 1/4 x minus 4. Okay, so that's going to give me a y-intercept of negative 4, and it's going to give a slope of 1/4. Okay, so I'm going to pick another color, like, say, green, and then we'll graph this in, say, green. Okay, so what I'm going to do is I'm going to do a y-intercept of negative 4, so I'm going to put my first dot there at that point. Then if I have a slope of 1/4, rise over run, both positive means I'm going to go up 1 and I'm going to go to the right 4 from that point then. So you're down 4, then you're going to go up 1, and then you're going to go to the right 4. Okay, like that. So we got this. Now what you need to do on this is not a solid, that would be an open interval, so we use a dashed line on that. So you're going to go dashed lines, just like that, and just kind of go through those 2 points, and then you'll have that. Okay, now and if you look at this particular inequality, since we solve for y, that means that we're going to be below. So I'm going to just kind of make an indicator to myself that I'm below. Okay, or you can use these little indicator lines like I showed you, like this, so we know we're below. So if you look at this, we're to the right of this line, and we're below this, so that means the shaded region has to be here. Okay, it's a good idea to bring like a highlighter to the test so you can write your solution out like that. So that is the solution of that inequality. Okay, now the other thing I'd recommend on this problem is, by all means, man, check your answers. Nothing to this. All you got to do is pick a point anywhere you want to in this shaded region. Just take a point. Like I'm going to take this test point. That looks like the point 5, negative 5. It doesn't matter what you use, just check this point. If it works, then you're probably right. So we're going to take the inequality negative, whoops, hold on, I need to go back to the beginning of the problem. Come on, erase. Okay, so what I'm going to do is, let's write down the original equation, negative x plus 4y less than negative 16. Okay, just plug in for x, plug in for y. So that's negative 5 plus 4 times negative 5 we're going to see if that's less than negative 16. So that's negative 5 minus 20, less than negative 16. So notice that it works. Okay, that's not enough though. You also got to check it in the second inequality, which is x is greater than negative 1. Well, all you got to do on this is take the x value of the test point you chose and plug it in. So that's 5 greater than or equal to negative 1. That also works. So that means that as long as your lines are okay, as long as you graphed your lines okay, then you have a correct answer. So don't forget about checking the answer on that when you do that. So that's called the system of inequalities. Is another thing I expect you to know how to do. Okay, next thing is graphing an inverse. And we've done, I think, this very problem many times. So just kind of a simple thing, a way to have you graph an inverse and check that your knowledge on that. So what you're doing is you're just taking these points. And if you're graphing the inverse, all you're doing is you're going to change the order of the variables. Then you got negative 3, 0. So on the inverse, that's going to become 0, negative 3. You have negative 1, 1. That's going to change to 1, negative 1. You have 0, 3. That's going to change to 3, 0. And then this point 4, 4 is going to change to 4, 4. So it's actually the same thing. So now what you're going to do is you're just going to plot these points. Then you can connect the dots. Okay, so I'm going to go ahead and just plot these points. Let's start with 4, 4. So that stays the same. 3, 0. That becomes that point. 1, negative 1. That becomes that point. 0, negative 3 is this point. Negative 2, negative 4 becomes that point. Okay, now what we're going to do is just connect these things into line segments, and then we'll have a good graph of our inverse. Okay, so let's go ahead and do these one by one. Sketch them, and then we have this. I'm trying to make this look all pretty and everything. Okay, so we got that, and then the last thing we have is connect one more line, and then we got our graph. Okay, and see, it should be symmetrical. So one of the things that you'll see on these problems is if you were to graph y equals x, now y equals x goes through points 1, 1, 2, 2, 3, 3, and even through 4, 4. So this thing should be symmetrical about that line y equals x. So visually, you should be able to tell you're right. A lot of times students mess up on this problem. They miss a point, and that means to me that they didn't even take the time to check and see if they're right. So you want to do that. Okay, so that'll be a good overview. You know, this doesn't cover everything, but it covers the majority of things that you're going to see on there. So hopefully this will help you to prepare for this. The thing is to work problems. You can watch this video or just look at the problems you need help with and scan through this if you would like. So hopefully this will help you to do a good job on the upcoming exam.